While we are on the topic of pollution, we can't neglect another related topic, which is acid rain. Because acid rain is a phenomenon that is ultimately caused by air pollution. Acid rain is precipitation that has a pH below 5.6. Normally, rain is slightly acidic with a pH of about 5.6 because water droplets in the atmosphere dissolve some amount of carbon dioxide gas, which turns into carbonic acid. This is normal and not a problem. But when other airborne compounds react with water in the atmosphere and generate acidic products, then the pH of water droplets can go dangerously low to the point where the precipitation is harmful to living organisms and the environment. This can occur due to both natural sources of pollutants like volcanic eruptions or man made emissions brought about by burning fossil fuels. In the realm of man made pollutants, the primary culprits are sulfur dioxide and nitrogen oxides, which are two of the criteria pollutants that we talked about previously. When these interact with water in the atmosphere, they form sulfuric acid and nitric acid, which lowers the pH of rainfall considerably and leads to a variety of harmful consequences. Firstly, when acid rain infiltrates soil, it changes the soil chemistry. It causes nutrients such as calcium, magnesium, and potassium to leach out of the soil. And you may remember from our soil chapter that these are essential nutrients that plants need to grow and survive. Additionally, when acid rain infiltrates soil, it causes mineral particles to release toxic substances like aluminum, which can then enter runoff and be carried into rivers and lakes and also be taken up by plants. The trees that you see in the upper photo have all been affected by acid rain, and it's believed that a combination of loss of essential nutrients and increase in substances like aluminum to poisonous levels is responsible for the effect that acid rain has on killing plants. In the human realm, acid rain also damages infrastructure. It can damage paint and coatings, corrode metals, and cause deterioration of stone, which is what you see has happened in the lower picture. Thankfully, acid rain has improved in the US over time. You may remember seeing these images side by side in a previous chapter. The left shows incidents of acid rain in the US between 1989 and 1991, and the right shows acid rain from 2019 to 2021. Previously, acid rain was prevalent in areas of the country where there was a lot of industrial manufacturing and coal-fired power plants. But in 1995, the EPA added an amendment to a piece of legislation called the Clean Air Act that restricted emissions of pollutants from power plants, and it resulted in a significant decline in incident of acid rain, as you can see. So this transitions us nicely into our final topic of the chapter, and that is air pollution legislation. In the United States, the primary piece of legislation regulating air pollution is the Clean Air Act. The Clean Air Act was originally passed in 1963, but it was not a very comprehensive effort. It basically established a program for research into methods of monitoring and controlling air pollution. In 1970, the act was amended in a way that made it much stronger. The 1970 Act authorized the Environmental Protection Agency to develop actual regulations that would limit the amount of pollution being emitted from both stationary and mobile sources. The priorities of the Clean Air Act have been to reduce air pollutants that cause smog, haze, acid rain, and other environmental problems, reduce toxic pollutants, which are the ones that are known or suspected to cause human health problems. And of course, phasing out the use of ozone depleting chemicals. As with many pieces of environmental legislation, in order to pursue these goals, the EPA partners with state, local, and tribal governments to ensure that air quality standards are being met in all areas of the country. And so, states have to submit what are called state implementation plans, or SIPs, to the EPA, showing how they are doing to meet the air quality standards set out by the Clean Air Act. And the EPA is responsible for assessing and approving those plans. And the standards for pollution and air quality established in the Clean Air Act are considered the minimum that states must do to control air pollution. They can choose to establish stricter regulations that require even lower levels of pollution, but they can't establish looser regulations than what the Clean Air Act lays out. If a state or municipality isn't meeting the standards for pollution and air quality, then the EPA is authorized to sanction that state or even take enforcement of the Clean Air Act regulations in that area. Overall, the Clean Air Act has had a profound positive impact on air quality in the United States. It has led to a very significant drop in the total level of emissions of the six criteria pollutants, even as the country's population and GDP has continued to grow. What you see on the right is a graph showing several metrics pertaining to the US. The light blue line at the top is gross domestic product. The orange is vehicle miles traveled. The dark blue is the US population. The red is energy consumption. And the lime green is CO2 emissions. And then the dark green is the emissions of the six criteria pollutants altogether. So the point is that even as these other metrics have continued to go up, or remain steady, pollution has dropped. Specifically, the six criteria pollutants fell by 59% between 1990 and 2010. So, this means that the country has been held to a stricter standard in terms of how clean our technologies have to be, and it's had a huge positive effect. Other data points that show the impact of the Clean Air Act include the fact that in 1991, there were 41 areas of the country that had unhealthy carbon monoxide levels. And now all of those areas have been able to clean up, and they're all within the limits of what's considered safe monoxide exposure. Airborne lead pollution, as we discussed previously, has dropped by 95% thanks to the phasing out of leaded gasoline. And of course, acid rain incidence has dropped by 68%. So, all in all, the Clean Air Act has been enormously positive for air quality in the US. Air quality still isn't perfect. Many metropolitan areas still have big problems with smog and ozone, but this piece of legislation is a good example of how regulations can better human health and the environment.